Three LEDs blinking using Arduino. Connect three LEDs to Arduino using resistor of 1 kilo ohms. We are going to make all the three pins high for 1 second and then low for 1 second, and it's going to be repeated more. The high means it's plus 5 volt and low means 0 volt. The other end of the LED is to be connected to ground so that when a pin is made high, the corresponding LED will glow. Upload the given code and observe the output. LCD interface using Arduino. LCD consists of 16 pins and they should be connected to the Arduino shield as shown. Upload the given code and observe the output. As per the code, the string Bhumi is on the first line of LCD and Yantra is on the second line of LCD. Infrared sensor testing using Arduino. Usually, infrared sensor module works with 5 volt. But here an extra component is attached to the module that will regulate 5 volt, provided you are giving an input to this module of more than 5 volt. So that is the main reason we are going to connect V in to this module and not VCC, because VCC is 5 volt and the regulator will not give a 5 volt with a 5 volt of input. It should be more than that. Using the variable resistor in the module, you can adjust the sensitivity of the sensor. Upload the given code and observe the output. To the program, when the sensor value is 1, it will show yes, and if it is 0, then it will show no. Ultrasonic sensor testing using Arduino. Ultrasonic sensor has 4 pins, that is VCC, ground, trigger and echo. So trigger pin is used to on the ultrasonic sensor to start sensing, and echo is used to supply the reply from the sensor to the Arduino. Upload the given code and observe the output. According to the program, the distance sensed by the ultrasonic sensor is converted to centimeter and displayed in the LCD. Photodiode testing using Arduino. Photodiode is used to sense the light intensity, and notice that the photodiode has a polarity and it should be connected reverse bias. That is, the positive of the photodiode should be connected to negative and the negative terminal of photodiode should be connected to positive. Also notice a resistor in between that acts as a voltage divider. Upload the given code and observe the output. Thus, when the light falls on the photodiode, the voltage across the resistor will vary and thus sensed by the Arduino and displayed on the LCD. LDR testing using Arduino. The principle behind photodiode and LDR operations are same, but LDR acts as a resistor that will varies according to the light intensity. Another important thing about LDR is it doesn't have a positive and negative terminal like a photodiode. Upload the given code and observe the output. motor testing using Arduino. We are going to connect the servo to the Arduino shield using a L-shaped bug stick as shown. Servo motor consists of 3 pins: the signal pin, VCC and ground. The signal pin is usually yellow in color as shown. Upload the given code and observe the output. According to the program, the servo motor moves from 0 to 180 degrees as shown. DC motor testing using Arduino. In order to connect a DC motor to an Arduino, we need a driver circuit that will actually amplify the current levels from an Arduino to the acceptable level of a DC motor. So the driver which we are going to use is L293D. This is available as a module as shown, and we have to do some small soldering works in this module for this to make it easily attachable to the Arduino. We have to solder the pins plus 5 volt E1 and E2 as shown. Notice that we are using a 6-pin L-shaped bug stick to interface between the Arduino and the connector of 6-pin. Take a 2-side 6-pin female array connector and connect one end to the Arduino and the other end to the driver module as shown. The driver needs a secondary voltage in order to drive the DC motors. For that, we have to connect the plus 12 volt and ground pins to the V-in pin and ground respectively of the Arduino. V-in pin should have a 12 volt DC, and that we will get from the power adapter which we are going to attach externally. The driver module comprises of an L293D module, and this module has 4 buffers in it. These buffers are used to amplify the signals according to the controls given from Arduino. So typically we can support 2 DC motors with this module, considering each DC motor has 2 terminals, that is a positive and a negative terminal, thus making 4 different terminals, and that will be connected to the driver module. Upload the given code and observe the output. As per the program, both the DC motors are rotating in full speed. Notice that the full speed is attained only with the addition of 12 volt adapter voltage. Remote sensor testing using Arduino. The remote sensor which we are using is TSOP1738, which is capable of receiving infrared signals at 38 kHz. ESOP1738 consists of 3 pins, the VCC, ground and the signal pin. The signal pin is used to transfer the signal received from the remote control to the Arduino. Upload the given code and observe the output. The program will only support for Universal Remote Control Protocol, which is nothing but the Sony protocol. Notice that for each button press, a number is displayed on the LCD. This is equivalent to the Sony remote control protocol.